What will our future look like? In my previous videos, we went over the events that were most likely to occur before 2250. In this video, part 3, we shall discuss what will be likely to happen in the much more distant future, past 2250. I'm not a seer, nor will I pretend to know exactly what the future will bring us. And with us venturing increasingly far into the future, events are getting more so theoretical, so please keep that in mind while watching this video. This video is also quite lengthy, so let's roll. Last time we left off in 2250, with humanity becoming a Type 1 Kardashev civilization, potentially capable of harvesting all the Earth's energy. The Centralia mine fire, which ignited under the town of Centralia in Pennsylvania in 1962, may extinguish by 2256. The fire is expected to continue burning for at least 250 more years according to predictions from 2006. By 2260, large-scale human settlement of the outer solar system is underway, and by 2280, antimatter propulsion has allowed much of the local neighborhood to be explored. By 2300, global human life expectancy is reaching 100 years, and biogenetic engineering has made superhuman powers common available. By 2500, the terraformation of Mars, once a dusty planet, may have been completed, allowing much new space to be saddled by humanity. By 2600, most of the remaining plastics, tin cans and other waste products from the 20th and 21st centuries have decomposed. During their time on Earth, they have caused significant environmental damage. According to predictions, the hellish environment of Venus can be terraformed no sooner than 2700. The Venusian environment differs much more radically from the Earth's than Mars. Its terraformation would require both orbital and rotational modification, as well as large-scale atmospheric transformation. On 16 March 2880, the 1 km wide asteroid 1950 DA has a small possibility of Earth impact, and the last of the Helium Centennial Time Columns monument time capsules in Texas is scheduled to be opened by 2968. By the year 3000, the average non-modified human would have an average height of 215 centimeters and a life expectancy of over 120 years. In the same year, sea levels could have risen by as much as 6 meters since 2000. Also around 3000, the Pillars of Creation will have been destroyed due to a nearby supernova shockwave, which was observed heading for the Pillars in 2009. Expected to reach the Pillars before the year 3000, their destruction will be visible on Earth around this year. Around 3050, Polaris will have been replaced by Gamma Cephei as the northern pole star on Earth. By the year 3100, humanity is becoming capable of constructing a Dyson swarm around the Sun. The Time Pyramid is a public artwork in Germany, of which the constructors are adding one block every 10 years. At this rate, it will be completed in 3183. Around 3500, the next polar reversal of the Earth will occur, as the magnetic North and South Pole reverse. Around 4385, Comet Hale-Bopp is expected to return to the solar system, as well as the Great Comet of 1811 and 4876. Around 5200, humanity can be expected to have become a Type 2 Kardashev civilization, able to construct a Dyson sphere. Also, in 5200, Iota Cephei will replace Gamma Cephei as the northern pole star on Earth, followed by Alderaan in 7200 and Deneb in 8700. Before the year 10,000, Eta Carina, one of the most volatile stars observed in our galaxy, will have erupted into a cataclysmic hypernova. It is expected to be bright enough to read a book by at night from Earth, even at a remarkable distance of 8,000 light years. Antares will go supernova around the same time. In the year 12,000, the Sun is exiting the local interstellar cloud as it's continuing its trajectory throughout the Milky Way. Around the year 15,000, according to the Saharan pump theory, the North African muson will move far enough north to convert the Sahara back into a lush tropical climate, as it was 5 to 10,000 years ago. In 22,000, the Chernobyl nuclear disaster site will have become fully safe again, as radiation has decayed to negligible levels by now. In 36,000, the Alpha Centauri system will no longer be the closest star to the Sun. Instead, the Sun's closest neighbor will now be Ross 248, passing as close as 3 light years from our Sun, which is succeeded by Gliese 445 just 7,000 years later in 42,000. Around the year 50,000, the current interglacial epoch will end. sending Earth back into an ice age, regardless of anthropogenic global warming. In 52,000, most chlorofluorocarbon emissions from 2000 AD have been naturally reabsorbed. And by the year 100,000, many of the constellations will have been rendered unrecognizable due to stellar motion. Also, around 90% of human-emitted carbon dioxide could have been reabsorbed by now. In the year 250,000, Loihi, the youngest volcano in the Hawaiian Emperor Seamount chain, will rise above the surface of the ocean and become the newest volcanic island in the chain. At a point before 300,000 years in the future, the star WR104 is expected to explode. It may produce a gamma ray burst that could pose a threat to life on Earth should its poles be aligned in 12 degrees or lower towards the Earth. The star's axis of rotation has yet to be determined with certainty. In the year 950,000, the meteor crater in Arizona, which is considered one of the freshest of its kind, will have eroded away completely. And in the year 1 million, Earth will likely have undergone a supervolcanic eruption, large enough to erupt over 3,000 cubic kilometers. An event comparable to the Toba eruption 75,000 years ago, which nearly wiped out humanity. Also before this time, Betelgeuse has likely exploded into a supernova bright enough to be seen from Earth, and humanity's descendants will likely achieve a Type 3 Kardashev civilization by now. In about 1,281,000 years, the star Gliese 710 is approaching the solar system within 1 light-year distance, which is enough to disturb the Oort clouds of both stars and send showers of comets into the solar system. There's even a 1 in 10,000 chance the star penetrating within 1,000 astronomical units of the Sun, where its influence on the Kuiper Belt objects and possibly the planet Neptune is significant. In about 2 million years, coral reefs will have completely recovered from human ocean pollution. And in 6.8 million years, DNA from the 21st century will have completely decayed. Any remaining biological samples from the 21st century, which have not been recovered or digitalized by now, are lost. In 7.2 million years, Mount Rushmore will have eroded away. And in around 7.6 million years, the Martian moon of Phobos begins to break apart due to orbital decay. It gradually becomes a ring system over the following 3 million years, with many of its fragments impacting upon Mars itself. And in about 10 million years, the widening of the East African Rift Valley is flooded by the Red Sea, causing a new ocean basin to divide the continent of Africa. Around the same time, most current species will have disappeared throughout the background extinction rate, with many clades gradually evolving into new species. Deprevitiy is a binary star system consistent of a sun-like star and a white dwarf. Because of the strong gravitational effect of the white dwarf, it draws matter from the other star near, which causes periodic thermonuclear explosions to occur. In around 10 million years, the system will approach the Sun and threaten our solar system with lethal levels of gamma radiation. In 25 million years, the movement of the San Andreas Fault will cause the Gulf of California to flood into the Central Valley, forming a new inland sea on the west coast of North America. In about 30 million years, the upward movement of the Anatolian Plate will have closed the Black Sea. Also in the next 40 million years, a 10 to 20 kilometer size asteroid will impact the Earth. In 50 million years, the African Plate will have collided with Europe, closing the Mediterranean Sea, forming a mountain range similar to the Himalayas. Additionally, the Canadian Rockies will have eroded away, and the absolute minimum time for Earth to replenish its natural resources will elapse. The entire current Hawaiian island chain has been replaced by new islands in 75 million years. And in 80 million years, Saturn's rings will likely have fallen apart. And in 100 million years, the Earth will likely experience a mass extinction on the same level as the Permian and Cretaceous extinctions. In 120 million years, Australia has fully merged with Indonesia, and the Atlantic Ocean begins to close following the formation of a new subduction zone. In 180 million years, days on Earth will be 1 hour longer. And in 240 million years, the Sun will have completed one galactic orbit. In 250 million years, a new supercontinent will take form on Earth. 3 potential configurations have been dubbed Damasia, Nova Pangaea, and Pangaea Ultima. This continent will break apart 400 million years from now. And due to the Moon's orbit receding from Earth, in 600 million years, total solar eclipses will no longer be possible. In 600 million years, the Sun's increasing luminosity begins to disrupt the carbon-silicate cycle, increasing weathering of surface rocks which trap carbon dioxide in the ground as carbonates. As water evaporates from the Earth's surface, rocks harden, causing plate tectonics to slow and eventually stop. Without volcanoes to recycle carbon into the Earth's atmosphere, carbon dioxide levels begin to fall. By this time, carbon dioxide levels will fall to the point at which C3 photosynthesis is no longer possible, meaning 99% of present-day plant species will die. In around 700 million years, the death of most plant life will result in less oxygen in the atmosphere, allowing for more DNA-damaging ultraviolet radiation to reach the surface. The rising temperature catalyzes chemical reactions in the atmosphere, lowering oxygen levels further. Many animals are driven to the poles or possibly underground. Earth will become a barren desert, and plants and animals will be primarily found in the oceans. In 750 million years, the Sagittarius dwarf galaxy has been fully absorbed into the Milky Way galaxy. In 800 million years, carbon dioxide levels fall to the point at which C4 photosynthesis is no longer possible. Without plant life, to recycle oxygen into the atmosphere, free oxygen and the ozone layer will disappear from the atmosphere, allowing for intense levels of deadly ultraviolet radiation to reach the surface. Some animal life may be able to survive in the oceans, but eventually all multicellular life will die out. The only life left on Earth after this point will be single-celled bacteria. Following up, in 1.1 billion years from now, the sun's luminosity has increased by 10% and warmed the Earth to the point liquid water is no longer possible. With the average surface temperature now at 47 degrees, the seas and oceans begin to evaporate. The atmosphere is becoming laden with water vapor, creating a runaway greenhouse effect. Any life left on Earth at this point would have to be able to survive under conditions similar to Venus today. Humanity's descendants may reach a Type 4 Kardashev civilization in the next 1.3 billion years. And following the runaway greenhouse effect, eukaryotic life on Earth will go extinct, followed in 1.6 billion years by prokaryotic life, making the Earth uninhabitable. In around 1.7 billion years, the habitable zone has moved outwards far enough to push the Martian average surface temperature above the freezing point. In 2.3 billion years, the Earth's outer core will solidify, shutting down its magnetic field. As a result, the Sun will begin stripping its atmosphere. In 3.3 billion years, Jupiter's gravity will have disrupted Mercury's orbit to the point it will have been either ejected out of the solar system, collided with another planet, or crashed into the Sun. In around 3.6 billion years, the Earth has heated to over 1400 degrees Kelvin, hot enough to partially melt the crust, and Neptune's moon Triton is expected to fall through the planet's Rouge limit, disintegrating into a ring system around the planet. In 3.8 billion years, the first of a series of galactic collisions between the Andromeda and Milky Way galaxy will occur. This is unlikely to affect the solar system due to interstellar distances being too vast. And in around 4.9 billion years, the Sun will exhaust its hydrogen and switch to helium fusion, swelling to a red giant and leaving the main sequence. And in 6 billion years, the Milky Way and the Andromeda galaxy will have fully merged into the elliptical Milkomeda galaxy. In 7.5 billion years, temperatures on the Saturnian moon of Titan will be sufficient to support life. Around the same time, the planets Venus and Earth are likely destroyed by the swelling red giant Sun. In 7.9 billion years, the Sun peaks its red giant phase, achieving a maximum radius of 256 times its present day value. In 8 billion years, the Sun will eject a planetary nebula and become a white dwarf around 54% its current mass. Temperatures in the solar system will begin to drop rapidly after this. In 22 billion years, the outdated Big Rip scenario could occur, disintegrating the universe. In 100 billion years, the Virgo supercluster will converge into one giant single elliptical galaxy, as will most superclusters by now. Around the same time, the universe's expansion is causing all galaxies beyond the former Milky Way local group to disappear beyond the cosmic horizon, removing them from the observable universe. In 150 billion years, the cosmic microwave background has cooled from its current temperature of 2.7 to 0.3 degrees Kelvin, rendering it essentially undetectable with current technology. In 1 trillion years, the number of years becomes too large for me to put on screen. From here on out, I will represent the number of zeros in scientific notation. In around 1 trillion years, star formation begins to decline in most galaxies, as the hydrogen needed to form stars is becoming exhausted. Around the same time, the outdated Big Crunch scenario could occur, collapsing the universe. In 1.8 trillion years, humanity's descendants could reach a Type 5 Kardashev civilization, able to control all the energy in the universe. In 20 trillion years, the first red dwarfs will run out of fuel and start dying. In 100 trillion years, the Stelliferous era will fade into the degenerate era of the universe. In around 130 trillion years, there will be only degenerate stars left in our universe. In 1 quadrillion years, the Sun will have cooled to about 5 degrees Kelvin, becoming a black dwarf. Many stars follow soon after. In around 50 quintillion years, galaxies are starting to fall apart. In 2.2 septillion years, the half-life of the most stable isotope known, Tellurium-128, expires. Around 1 nonillion years into the future, black holes will be the only remaining objects left in the universe. In 2 undecillion years, protons, the particles that make up atoms, have a chance to decay, breaking apart all atoms in the universe. Okay, now let's get ready to tackle the really big numbers. In 17 quattor trigintillion years, my god, I can hardly pronounce that, all black holes have decayed due to Hawking radiation. At this point, the universe has expanded so far that there isn't enough energy available to keep any particles together. From here on out, the universe is in its dark era. In 10 quinquaquadragintillion years from now, there is a 95% chance of the universe false vacuum having collapsed. So in about 1 novenagintilquadragintillion years, all baryonic matter has decayed into iron-56. In 10 to the 10th to the 65th years, a Boltzmann brain will appear in the universe due to a vacuum quantum flux. In 10 to the 10th to the 120th, the universe will reach its final energy state of maximum entropy. And finally, in 10 to the 10th to the 10th to the 56th years from now, due to quantum tunneling, any isolated patch of the universe's vacuum could generate, throughout inflation, new Big Bangs giving birth to a new universe. So that was quite a lot to cover, wasn't it? I hope you stuck with this video till the very end and could comprehend the numbers. It was certainly hard enough for me. The background of especially much of the later events needed some extra explanation, which made this a lengthy video. I hope you enjoyed this 3-part series and make sure to check out more of my content on my channel. Thank you for watching.